So, a little while ago, I watched the Netflix show Three Body Problem, and it sparked a little bit of an obsession, so much so that I even got the book and fell in love with that universe. I mean, just amazing world building, and the ideas in it are so out there, so far stretched. And warning here in this video, a slight spoiler ahead. Now, obviously, the show is called Three Body Problem, and I won't say too much, but essentially, in the book, there's these aliens who come from Proxima Centauri, which is a real star, and this is a three-body system. And because it's a three-body system, it is unbalanced in classic Newtonian physics. And essentially, they can't live on their planet because it's going to be ejected, or a star is going to collide and it's going to be uninhabitable soon. So they come to Earth and say, we're going to come over there and take your planet. Now, what is the actual three-body problem? Well, we discovered it when we were trying to simulate the inner solar system in one of our earlier models. We discovered that Mercury and Venus would kind of collide with Earth sometimes. Sometimes Venus would collide with Mercury, and their orbits would go sporadic because they're all influence each other according to classical Newtonian physics. There's a whole formula here. If you want to do the math and check it out yourself, you totally can. But as you can see, this little randomness going on over here shows that it's completely unpredictable. And I'll show some more simulations here that other people have done, great 3D renders, where showing that these systems behave completely sporadically and most of the time end up either colliding with a star or ejecting the planet orbiting it. So obviously this chaotic star system is the reason behind the motivations of these aliens. So the question comes, does this work in reality? So let's pull up Universe Sandbox here and create a new simulation. And for the sake of example here, I'm going to take three stars that are the exact same stars. So we're going to use Proxima Centauri here because you want a similar mass. And let's put them in a perfect triangle. Relatively perfect. A triangle. And let's see what happens. Speed it up here. They start to form that spiral pattern already. And looks like one got ejected and we got a supernova. Okay, same exact situation here. Let's see what happens. Speed it up. We got an early supernova. Speed it up. Let's try to be a little more random with the selection of putting them here. And an instant supernova. Let's do that triangle pattern again. Oh, that was weird. We didn't really get a supernova there. Oh, it seems to have shared some mass, and we got a supernova. So as you can see, this isn't really a stable star system we got going on here, but let's play around with the masses a little bit. Let's get different stars here. Let's get something of similar size. Okay. There we go. We got three different stars of different masses to make it more realistic. Let's see what happens. And the star is ejected. And then it fell into a stable binary orbit. Now this is what normally happens in these systems. It always ends up either ejecting a star or colliding with them, and stars end up staying in a stable binary while the other one leaves. And we can do this with planets as well to show y'all the behavior in like a smaller scale. Oh, and here, let's add the moon here for fun, just to simulate a planet. Oh. And the moon's ejected. Definitely anything alive on that planet would be dead. Oh, Alpha Centauri A and Alpha Centauri B. And Alpha Centauri A and Alpha Centauri B, let's compare it. to Proxima Centauri. See how small Proxima Centauri is compared to these stars? Proxima Centauri is a red dwarf, while Alpha Centauri A and B are both yellow suns. And this is not accurate to size, but this is essentially how the Proxima Centauri system works. It actually ended up getting ejected, so let's try that again with a little farther distances this time. And there we go. Now, as you can see, this is stable. So it isn't true that a triple body system is necessarily inherently unstable. Because if that were the case, our solar system wouldn't be stable as it is. To show you how complex these multi-body systems can get and actually achieve stability, there's this great simulation here in Universe Sandbox that's already made called the Ultimate Engineered Solar System. And just look at all these planets. They're all counter-rotating each other, all in the Goldilocks zone, all habitable. Just go to one. Look at that. It's a blue planet. And these systems are actually very stable if they're done right. It can be perfectly habitable. So just for fun here, we got Earth, a planet, orbiting the star here in this system, just to show you how chaotic this would really be. And the fact is, like, life evolving in a system like this seems like a 1 in a billion trillion moonshot chance and not really realistic. However, it is an interesting idea to give them a reason to want to take over Earth, I suppose. But yeah, I don't think you have to worry about the Trisolarans taking us over anytime soon. There they go. Boom.